I just could not get that line to fit. I tried my best. I tried to fit that line as best I could, and it just didn't work for me. So I've decided the best place for that line is in a scatter plot. So let's put it in the scatter plot and leave it where it belongs. This is a scatter plot that is showing a positive correlation, and it involves the temperature, outdoor temperature, and the amount of money made in ice cream sales. The next graph is the same graph. However, I've inserted a line or an arrow in the data points. And notice how it is roughly centered in the data points, kind of like an average or a mean part of the data points, and it runs straight through it. We call this the line of best fit. Now we can use this line in order to help us make predictions about situations. So let's go to the third part of this graph. Now notice that I have removed the data points, and now I only have the line of best fit left. Well, I've also done an example here where if the outdoor temperature is about 85 degrees and you go straight up from the x-axis until you get to the line of best fit, and then you go over to the left until you get to the y-axis, it stops at a rate right around, hits the point right around $490. So what we can assume or predict from this graph is that when it's 85 degrees outdoors, we're probably going to make about $500 worth of ice cream sales. This example involves the cost to heat your home and the outdoor temperatures. Well, this is showing a negative correlation. Now let's take a look at the line of best fit. Here I've inserted a line of best fit for these data points. Notice again how I roughly went through the center of the data points. I didn't try to necessarily hit them all, I just kind of drew it through the center portion of the data points. And what we can notice from this or determine from this is also making a prediction about how much it was going to cost to heat a home from this data. So if we look at, say, 20 degrees outdoors, so if it's 20 degrees outdoors, we can go straight up from that x-axis until we get to that line of best fit, then move directly horizontal over to the y-axis, and we can see that it lines up with somewhere right around between 220 and 225, which would be about $212, $213. So from this, we can predict that you're going to spend about $213 roughly if the outdoor temperature is about 20 degrees. The data in the other scatter plot videos and episodes that I've done has been true actual data. However, this episode, the data is fictional, it's false, it's fabricated, it is not real. I made it up just to be able to demonstrate or show you the line of best fit and what it is to give you an idea. And that is it. That's my disclaimer for this episode.